bottom, problem 62 in book. Here is this data set. Uh, it's also a problem from section 3. I forget which problem it is. It's not 62. But I'm going to quickly create a scatter plot of this. And when I look at the scatter plot, I can see that, gosh, it seems like the data values are following a nice linear trend. I'll come over here, find the correlation value equal to correl. And I'm going to highlight data, comma, next data set, return, and look at this, nearly perfect, almost 1. Let's find our least squares regression line. I'm going to right click on an ordered pair, add trend line, display equation on chart. Here's my regression line. So now let's find the predicted values. And I'm going to again enter my least squares regression line here, times my x variable, my explanatory variable, which is this one right here. I hit return, and notice that the response, the observed value, was 6.55 for this variable called response, but I predicted 11.16. Next, I find the residual. And again, it's going to be the observed minus the predicted. Hit return. There's my residual value. So the difference between the two is these 4.61 units. Now I'll highlight both, drag, and I get the rest of my residuals. What I'll do next is create my residual plot. So I'll highlight the first column, hit the control key so I can skip these other two columns, and then highlight my residual column. Go back to insert, click scatter, and something doesn't seem right. Well, one thing I'm noticing is, which I probably would have been apparent from the data value, is that all my points are below the 0 line. That's not good. I must have done something wrong. Let me try again. I'm going to go look at my predicted, and what did I enter wrong? Oh yes, I entered plus 10.008, not negative. So let me come back here and enter negative. That should, oops, negative. That fixes it a little bit. Now I'm going to have to get the rest. Oh, now I see that residual is 15. Let me now click here in the lower right hand corner, drag to fix the rest. And that fixes the residual plot. Oh, now looking at my residuals, things don't look too good. Again, let me emphasize where y equals 0 is at. There's y equals 0. And now I see that something is terribly wrong. Look, see these points right here? It turns out that these represent these first 4 or 5 values. But look how close they are to each other. That's good. This is for 0.25 of this x value. But what's not good is if this, I'm randomly selecting from a normal distribution, all these values are not only far away from the regression line, but all bunched up together in one side. What about the next group? When the x variable is 1, again, they're very tightly grouped. That's not a bad thing. But what is a bad thing is they're tightly grouped but not around the regression line, which is this line right here. These points should be some above, some below. This is not looking good. As a matter of fact, number 5, the next value, also suffers from the same problem. And this one's the only one that seems to be a little bit above below only because of this one value here. So what does this mean? It means that while this plot looked perfect, look, everything's lining up like it should along a straight line, this one here tells me that no, things are not looking good. Um, it's not a straight line at all. This model is not straight. What is it? Who knows? But it's certainly not a straight line model. So the moral of the story is that even though, notice, our R value is nearly perfect, almost 1, even though the visual here of the scatter plot seems to suggest that it's a straight line model, the residual plot, what it has done is amplify all these values so I can see how they're scattered around this line. And because this line is, again, diagonal, again, our eyes may get fooled. Here, of course, there's nothing to fool because these points are so tightly grouped, we could barely see how they are scattered around that line. But again, the residual plot here amplified that, and I could see that they're not evenly distributed around that line. So the straight line model is no good. Now, why did these points look so good in the original plot? Well, one thing you could look at is there's a couple problems. Look at the values of the y. Notice how, look at that scale. It's jumping in value, it's going from, let's see, a response of 6 to a response of 900. That's quite a jump. And now also look at the x variable. We're starting at 0.025 and ending in 20. There's a huge gap between the smallest, the largest, and everything in between. Everything is spaced out. Put it out all together, and you have all of a sudden the situation where everything looks very nice here. The R value is very large, but we don't have a good linear model. So that's the idea of the residual plot. The residual plot is going to amplify how the ordered pairs scatter around the regression line, and hopefully what we want to see is a model that suggests that indeed we sample from a normal distribution. In other words, so when we start sampling, some points land to the right, some points land to the left, but with a 50-50 chance, not favoring one side nor the other. All the normal distributions here have exactly the same standard deviation. So all the points should be scattered evenly around a straight line model. And all the centers of every normal distribution, again, are connected with a straight line. So when you look at the ordered pairs, they will again follow that straight line pattern. And that's what we hope to see.